Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. Just a little here. We have a whole bunch of arcade power supplies. These are newer than the old originals that were in most of them. These are the modern switching power supplies. Run a lot of the old ones, and that people swap them out, and then run a lot of the new cabinets. Supposedly, yes, I did.
I didn't know.
It's okay. So supposedly, these HAP are supposed to be pretty good. I don't know about this Peter Chu Power Master XL or X22, so that's a 12 Power Master 12, I think. Anyway, these are all supposed to be bad. Ignore that good there. I'm going to tear into them and we're going to see what happens. I have opened up this one, and obviously this one, because it was missing parts of it, did do a little probing around with my, this thing just slides out. Okay. With my multimeter. I had these two separate. I had these in a box in storage waiting to get to them. So I just did a little probing and checking on some stuff, and I know these have got shorted switching transistors, but we'll get to all this. This one's like got a broken piece there. I think this one doesn't, so it's good. We got a parts one to work on this. This one may be unique, and this one looks different in the way it's laid out compared to these three, so it might be slightly different. But we're going to be working with mains voltage. We're going to be putting mains voltage in. So, I'm a goober. Don't do what I do if you're an idiot. You can get shocked. You can zap yourself. Does all kinds of precautions. If you can't handle it, don't try it. That's your warning. So first thing I'm going to do is we're going to pull some of these apart. I'll try to keep the two together there. That one there. These three that are exactly the same, and then we'll see what this one looks like, and I'll just fast forward it through, and I'm going to hit the mute button. Oh, I'll probably turn the overhead light on, so there might be some glare, but I'll try to monitor that while we're working on stuff and troubleshooting. Okay, so the two Power Masters are a slightly different design. This one says it's a Chungyu PCB. This one doesn't have anything like that on it. They are really similar. It's got a light. This one has no light whatsoever. I don't know if we'll be able to steal parts. This one's left straight that's broke, but I bet we can still use this. So on this one, get my spectacles here. Yeah, I don't know anything about that one yet. This was the one that was missing parts of its cover. I know I have. I swear I did. Thought I did. I thought I desoldered. Oh, I think it's on this one. Okay. So, you know, we're just going to look it over, looking for blowed up stuff. You know, they're dirty. Notice it uses. Get to focus. TL494, same chip. TL494, same chip that's in the power supplies of car stereo amplifiers, a lot of them. So those aren't very much different. One thing we will do as we go, get the old multimeter out here, put the rest on so that we can hear the beeps. Fuses appear good in these. This is the Peter Chow, CHOU, I believe that's Chow. It's got a TL494 chip in it too. If nothing else, when we're scrapping these out, I'll be saving stuff like the chips and stuff. The caps all look good. We do have a fuse here. These are all supposed to be not working. This fuse says it's good. I mean, assuming you're still really supposed to take fuses out to check them. But looking around, there's just glue residue. Don't see anything jumping out at me. So this was the hap that looked different than these. And it is. It is a whole lot different. As a matter of fact, it's not that. Not that. Not that one. Okay. Well, does not match up with any of the others. That one here. So this hap is the one I think I took apart. Yes. See where I desoldered the legs. Yeah. On the FETs, I know one of those MOSFETs are blown. I just went through, we're going to do that to the others. We're just went through and was testing for shorts. Found it, pulled them. They were both shorted. They both show shorted, but actually only one of them shorted. And then we have a fuse here. Fuse is good. I can go here and show you on the FETs. That's reading shorted. That's reading shorted. It's actually one of them's reading shorted. Or one of them's shorted when you take it out. I pulled the one little screw out and stuff. We'll show you that in a minute. We got this one or that one. So we already kind of know there. Oh, looky right here. So right off the bat, if you look at the side profile, you see that cap is swollen. It's got a fuse here. Fuse is bad. So let's see. Find a marker. Put F on there. Well, you can't see that. I don't know where my other better colored markers are, but there we go. It's got an F. So we know the fuse is blown on this one, and we got a cap. at least that's swollen and bad. So the next one here, I see these two caps are swollen. Let's see. That one's really swollen. That one's already started to swell. Those look okay. Whoa, I can see blown fuse right there. So, right, fuse. These caps. Some stuff we've seen. So that's two of these. This one, swollen cap here. See how it should be flat like this. That one's swollen. Those legs look like somebody's already soldered some new ones in at one point. Somebody may have fixed this one. Do they all look like that? Well, that one looks like that. Maybe those were the hand. Oh, look at here. Something got hot right there. That's where that cap is. Oh, and I see some burn marks down in there. So around this resistor and stuff. So that one got a little crispity. It's got a blown fuse. This one's got a blown fuse. This one cap here. And that's a blown fuse. Fuse go across that. Definitely blown. That one's good. That one's good. That one's good. That one's good. All three of the haps that are the same. Fuse, and I got some caps here. Have blown fuses, and all the rest of them do not. So what did I say? I knew this one had a blown MOSFET, but it didn't blow the fuse. That's funny. So that's a hap also. I wonder, is this the newer style or is this the newer style? These are changeable to 115 to 220. They look all exactly the same. Trying to look and see. Continued protection against fire. Replace only with the same size fuse. R35, R35, R35. Oh, that's probably telling me that resistor. I was trying to find a board revision. Pan, yes, 9312. Just don't have anything on them. Looks like that got a little hot right there on that inductor. Now, some of these may have just, because the caps on these and these went, may have caused the problem. So we got three down here that all three blew the fuse, got bad caps in them. So we'll have to check some stuff. Which one? This one right here. We're going to put a star on it really big. Because it's the fried one. And it's the fried one down in here. A little zoomed in more. down in here. So we'll probably use it for parts to fix up 2 of these. This one I know has got a bad rectifier, or not rectifier, MOSFET. I haven't a clue on these others, so I thought it was one of these that I swore I took out. The other. It's like something got a little toasty or sparky there. We got some bad looking solder joints. Oh, yeah. That resistor right there. See it wiggling, and it's all burnt to pieces. So. Awesome. This is what we're going to play with. So I'm going to start. Everybody says the haps are better, so let's retire. Since they're not the same, let's retire these other weirdos. Let this hap. I know what's wrong with it, so as we go, we're going to look and see. Let's go ahead. I know what's wrong with part of it anyway. It's blown at least one MOSFET, so let me get this out of here for you, and we will so these are the switching FETs right here, and we will test them. So that's the blown one. Little transistor tester over here. A good one in. Oh, it's not a FET, it's a transistor. It's a BJT transistor. And it shows that it's okay. Possibly functional. Get this one in here. Test, and it should show definitely bad, but we've already tested it with multimeter. We know it's bad. Yeah, it just shows up as some diodes. So, hang on, which one was the bad one? Bend its legs around so I know which one's the bad one. So, we're going to be looking. I don't know if you can see the part number on this or not. For J13007-2. Part number on there, so we'll have to see what we got here. So let's just stack these. The one with the star we're not going to worry about. We've got a blown fuse. Now here's what I'm going to do is double check the fuse. Fuse should be going from here to there. Nothing. Things that like to blow besides these caps. We already know some caps are bad, and I'll have to maybe look about seeing about ordering some caps. Rectifiers like to go, so we have bridge rectifier that says positive, AC, 2 AC legs in the middle, and then the negative. Make sure it's over here where you can see it. Okay, so we got a rectifier drop there, a rectifier drop there, and then if I switch it around, we should have a rectifier drop there and a rectifier drop there. So what you're doing is you're looking on the positive one, you put your negative probe, your black, and then you go between the 2 ACs. And then on the negative one, you put your positive probe because you want to see a diode drop. And that's going to work. If you get a little beep, that's okay because there's normally a capacitor, in this case 2, that are across there that you might be charging up a little bit. So that rectifier looks good. We got the 2 switching transistors here. So let's check those. Seems like we have a short. So, fire up the desoldering rig. Maybe a common problem with these. You know, we got that other style too there. So we're going to go ahead, see about pulling that out and see what part number they are. I may have to order some parts. I don't carry a lot of high voltage transistors. Can tell you this, the clamps are the same. And while we're waiting for that to heat up, that is a J13007-2, so it's the same thing as these. So we get these out, and we might end up with a good one. They're not going to be matched pairs, but, you know, we're going to do the best we can. And sorry, I had to get a little swallow up. Drink my drink. Technically, one should be one way and one should be the other. So it shouldn't matter, but just fell right out. That's perfect. That one was this one. That was that one. It was Q2, Q1. See what it says now. That one's good short all the way across. That one's shorted. So both those are bad. I think I'm gonna have to order some of these. Let's go to this one. Like I said, we're just jamming through it. I already found that, playing around, found this bad one. We've just now found FETs. And the switching power supply, I've said it in my amp repair videos, is learning switching power supplies, you know, super important. I'm not teaching you a ton here except how to quickly go through troubleshooting them. If you want theory, somebody else is better at giving you theory. I watch the theory videos all the time so I can learn how to fix these better. But I'm trying to point out, you know, check fuse, look for silly stuff like swollen caps. We're going to go straight to the bridge rectifier here. Oh, no, we need to be the other way. Sorry. Voltage drop. Got a voltage drop. Got a diode voltage drop and a diode voltage drop. If you don't get those readings that way, something's wrong with the bridge rectifier. So we know the bridge rectifier is probably good, so that's going to go into these caps. That's going to give us our main voltage. This chip over here is going to control these switching transistors to give us the main voltage and some of these auxiliary voltages. Because these have, or what do they say they got? The main part is 5 volts, like at 15 amps or 10 to 15 amps. Then they also have plus 12 and minus 12, I believe. Okay, no, they have plus 12 at 2 amps, minus 5 volts. So there's going to be a little 5 volts at 1 amp. So the main is 5, then they got a minus 5, and then they got a 12 volt. So we know that's okay. Go right here on the other side. This is kind of a little bit of the line of the high voltage side, and then the other side. Here's our switching transistors. I'm just going to go to them. Shorted. Shorted. Oh, I'm going to take the screw out first. And that's the beauty of switching power supplies is they're once you start getting into them and start understanding that, you know, power comes in, it gets some filtering and stuff, but it goes to the bridge rectifier, becomes DC, and then it's going to get switched by a pair of transistors controlled by a chip that, you know, to give you your power out. And then we've got some extra stuff here because we got multiple voltages coming out. So we got multiple voltages coming out. This is the 5-volt adjust because this is for arcades. But these are the 1307. So the same FET again, or transistor again. I did not have this heated up. But these are the same transistors again. We pull these out and see. If we end up with a pair of good ones, we might try to rebuild one of these, but we got some bad caps too. While I'm looking, that should be the cap. Marked on the board. That's good. It shows negative and positive. So now we'll know about that one. And I do have an ESR meter. So we will check some of these caps as we pull them out. This might take a couple videos because I don't want to make it too long. If you happen to cross, it's going to be that side. If you happen to cross, I just marketplace like crazy. Find somebody that's selling some stuff, and I notice things in the background. And I just got lucky with a gentleman that's got some arcade stuff that he's getting rid of, and he's getting rid of it all. This was Q2 and this was Q1, just based off the markings here on the board, Q1 and Q2. Just trying to keep track. It really doesn't matter. This one had both blown, and I'm not sure what that one had, but so that one's bad. They all bad. Well, poo. So, an ESR meter allows you to test your caps. And this one says 0.8. This is a 33 macro, 16 volt, somewhere in between there. You know, the ESR might be okay on that, except for the fact that it's swollen and getting ready to go. So the other thing we can do, stick it in this tester. Make sure you discharge them before you put them in transistor testers. They no likey. Charge cap. They need to be able to charge it so they know. Got something on our tooth here. Unknown or damaged. Let's make sure that we'll add probes here. Make sure we are testing here. Make sure that was good connection. It thinks that's 2 diodes. I don't know how it thinks that's 2 diodes. That's squirrely. Don't tell me this thing is went to crap on me. Somewhere I have another one of these. And it's not jumping out at me where it's at. I got this one because I liked it because it had an off button. It used a 9-volt instead of the little rechargeable lithium in it. No, we're going to leave that out. And those were bad. Let's go to this one. This one's got blown caps here. And a blown fuse there. And it's the one that's cooked up down here too. But it's got a couple good caps here. Let's just jump straight to bridge rectifier. Here. Voltage drop. Camera. So this is the two AC legs if you look at the bridge rectifier. And then this one is the positive and that one's the negative. Is that right? Positive, that's what it says. Oh, so you do put your positive lead to the positive. You do your negative here and there. That reads good. And right now, if I check across the positive and negative, it says I have a short, but I guarantee it's going to be. I got shorted transistors. So let's take these out and prove that that short goes away. Could have tested that on the others, sorry. It's just what I do. I find broken electronics and stuff that I'm interested in. A lot of it's old school. I like the old school stuff. Old arcade, old school stereos, you know, I got some old school computers and stuff like that, that I'm gonna, repair, hopefully. Some cool stuff. So give me a second here. All right, had to take a 2-second break there and get my stuff straightened out so I can look up that transistor, which I'll show you in a second. Let this part gun heat back up. Q2, Q1. Let's see. Both of these are bad. That one's dead short all the way across. So's that. Well, poop. We're going to have to do some magic of YouTube, because if I go over to this other screen, here is the parts. They got some in stock at Mauser. They got 3 different ones. Always filter by in stock. These two are at end of life. And this must be the current. Saying stuff about the silicone transistor, high voltage fast switching. So if you scroll over, they're all 8 amp, they're all 400 volt, 700 volt, 9 volt, 3 volt, everything's matching up. So it doesn't matter which one I get, except when you look at the prices. So the newest one is actually cheaper than this one that's into life. They have very little in stock, but they got some of this. So I'm going to go with at least 10. Continue shopping. So I've added that to my cart up here. And so that's good. So we need some of these transistors. Really very much bad. We got 1. Let's see, we're going to need some caps. These are all clamps for these 3. These are all bad. That's the one good one, but we ain't gonna reuse it. So I go over to the old Mauser. Show you how I do this. Products. This is a passive component. So we go to passive components and you'll find capacitors. And it is a aluminum electrolytic. So we're going to look at that. And then let me switch back here. So this is a radial lead. Axial would have one coming out of each side, one of the terminal strips coming out of each side. So when they're both coming out, it is radial. So let's go radial. And then I'm just going to read it. It is 16 volt, 330 microfarad. Some off-brand, but it is 105C. So those are important things to get off there. Also, if I have it here somewhere, my workbench is a mess. I'll look for it in a second, but where have I put my calipers? Be loud and noisy. Could get a big fat head in. So if you get some cheapo calipers, you can measure. Here, center to the center. That's about 7.6, 7.5 millimeter spacing. And for the legs, the outer diameter is going to be important. It's a 16 millimeter. We're not too concerned about height. We can go pretty tall. So normally the height is sometimes it's important, but we can go up to 40, almost 42 millimeters, about 40 millimeters. So let's go back over here. We know we need 3,300 microfarad. We need 16 volt. It was 105C. Oop, that's slid over really fast. Here we go. Lead spacing, 7.5 millimeter, and we want the diameter. Here we go. Diameter, 16 millimeters. So let's apply all these filters. We're left with 23 results. And the links in the nice thing about Mauser is it gets rid of everything for you. So the links were all under 40 millimeters, so we could use any 23 of these 23. So I kind of just start looking at the price at about 10 is what I try to buy. Each one of these power supplies is using 2 of these, and I bet this is for the 5 volt. So, and then I look at over here at the brand, and then we'll get into more important stuff. But we want to click over here, in stock, apply filter. So now we're down to 6. So we only have 6 to choose from, and if I can get all 6 on screen, just barely can't. So we got a $2 one, a 99-cent one, a $2 one. Whoa, we're not buying this one. This Bechet Sprague at 566, not that important. $1.98. So first thing I'm gonna do is I like the price of this one. It's a Chemet, which is an off-brand, which these all had off-brands in it. At 10, what's that on 10? $1.50. $1.53 is the next cheapest one if I ordered 10, and it is a Nichicon. And they have 60 in stock and 400 on order. So I can select that Chemet and that Nichicon. I believe I can compare them, and this will give me the stuff, some of the some of the things about it. They're both 25 millimeter. So the Nichicon, much better hours here. They're both 105C because we said we wanted that. We got a good thing. General purpose for the cheapo, low impedance electrolytic capacitor. Ripple current is less. That Nichicon is better there. Tells the series. They're both 20%. This is why it's a little more, because it is the Nichicon is a miniaturized size, so they've worked at it to with low impedance. So there is some really nice features about this, but I don't necessarily have to have it for these. These had off-brand PC Tour. Let me show you. There's the brand. PC Tour, who knows, some kind of off-brand. Is that what all the brands are in this? PC Tour, and then what about this weirdo one? It's got all kinds of different stuff, but they are, yep, PCE Tour. So it's probably a Chinese brand or Korean or wherever these were made at. So I'm going to go back over here to the left screen. Since this is not critical for sound or super duper stuff, you know, we're going to be just its bulk capacitance. I'm going to go with the Kemet. You know, I don't need it to be awesome. So we're just going to go to it. It's the cheapest. If I buy 10, I should get them for $7.50. So we'll continue shopping. And so that's how I buy caps. Kind of simple. You know, you got to make sure they're going to fit in the diameter is normally important because they sit beside each other. So I'm going to do that twice more. One with a 1,000 microfarad 16 volt here, and a 1,000 microfarad 25 volt. So these two are probably for the smoothing for the 5 volt because it is the high current one. Then this 25 volt one is probably on the 12 volt rail. It's only 2 amps. And then this other 1,000 microfarad is probably on the negative 5 volt. So that should get us there. Underneath here is a rectifier. So that'll get us a few caps. I'm going to go ahead and do that. Through the magic of YouTube, will either be part 2 or the parts will be in and we'll continue working to try to get at least one of these up and going. Yes, I could. It's not worth trying to rob or steal caps from one of these to try to make others. These are bad. These all show good. These look good. I got a good and a good, but 2 bads that were there. Not really worth it. This one's totally different. So these are both bad. So I think I'll do that. I'll peek at the others, either off camera while I'm ordering, or it'll show up in video too. Maybe we'll see what happens, you know. But anyway, we're going to get these going. Like I said, if nothing else, when you pick up some power supplies and stuff, even if all these ended up junk, as long as these chips are good, which I can test. Oh, that one's a KA7500. There. Focus on KA7500, which is just a different manufacturer's part number for the same thing as the 49. These all got the KAs. Does this one got the KA? Nope, that one's got the TL494, which those are completely interchangeable with each other. It's the KA7500 and the TL494, and the TL594 is also interchangeable. So those will all work with each other. And so nothing else, even if I didn't get these working, I want to get like 2 working out of all this pile maybe. That'd be my goal. Keep the rest for parts for now. Just because I've got some arcade boards to repair and I need to have some of them. I already got my 1 power supply, which I'll have to look back at the video. Maybe it matches one of these on the insides. I'll do that before the end of this video, maybe. But anyway, I need some to just sit there and let the game run so they can get hot, figure it out, because sometimes not every problem is just that it won't boot up, arcade game won't run. Sometimes they run and they have problems as you start playing them or as they set, because most arcade games, kind of get left on all the time. Not always, back in the old days they did, but so I need a couple more power supplies, and I had all these junk ones I picked up for nothing. Guy was going to throw them out because he replaced them already. He was he had a bunch of video games that he would put on locations, and so I just snagged up all this stuff that was going to the recycle bin, and I said, hey, I'm going to do that, and if I end up getting a couple working and the rest don't, then I'll put the rest in the recycle bin or keep some for parts and stuff like that. So, I also need to look up some fuses. I may add that into this video. These are 3 amp with legs, so maybe I'll show you that. If so, we'll insert it right here, all the little extra stuff. If not, it'll be in the second video. If you learned a little bit, hopefully you enjoyed that, showing how I order stuff and quick troubleshoots to basic switching power supplies. Pretty common that the transistors get blown when things start going bad. These had caps going bad in them. Turn these all had caps going bad in them. The load keeps going. When the caps are going bad, it increases the load and it can pop your power supply. We did take these out, and we were going to check for the short across the outputs. Look at there. No longer, oh, you can't see that. No longer a dead short. We took out the 2 shorted transistors, which makes sense because they go right over here and go right into the transistors. So, they do also fill these bulk caps. They got some discharge resistors on them, which is nice. But I'll show you getting, either in this video or the next, I'll show you getting these and the other parts. Maybe I'll get on order. We'll do Magic of YouTube or part 2. We'll see what happens. Anyway, if you found this informative, drop me a like and a comment and subscribe and click the little bell and stuff. I'm always pressed for time to try to do videos, and even when I get them video recorded, editing takes me forever. I have a full-time job, so I just do what I can to hopefully help some people out, and especially people that are interested in it. Learning switching power supplies allows you to fix all kinds of stuff. Your TV, monitors, computers, laptops, arcade stuff, amplifiers, switching power supplies of some form or another are in everything. Little charger that charges your phone and your tablets and all your stuff there. That's a tiny little switching power supply. Like I said, appreciate you guys. Hope you liked the video. Do all those things. See you shortly.